The range of a piecewise function can be a little bit harder to find than the domain, mostly because the pieces of the range, unlike the pieces of the domain, can overlap each other. We also have to deal with the fact that while the expression of the function outright tells us what the pieces of the domain are, we need to do some work to figure out what the pieces of the range are. But what we see is an expression for the y value in terms of the x value. So we take our inequalities for x, and we do to the x value in them whatever's being done to our x value. So I'm going to number my pieces, just so I can refer to them easily. Piece 1, we have -2 is less than or equal to x is less than 1. Our goal, we'd like to be able to say what 3x compares to. But we can multiply each position in our inequality by a 3. So -6 is less than or equal to 3x is less than 1. So one piece of our range, remember 3x is the output value of the function. One piece of our range goes from -6 to 1. Okay, that wasn't too bad. Let's start working on the next piece. On the next piece, x is between 1 and 5. And we want to get to 4 minus x. So to have 4 minus x, we need our x to be negative. So I'm going to multiply each of these expressions by a -1. Remember, whenever I have an inequality, if I multiply or divide by something negative, I also need to reverse the direction of the inequality. Now I have -x in the middle. I want 4 minus x. Well, to go from -x to 4 minus x, I'm adding 4. So I'll add 4 to each of my expressions. -1 plus 4 is 3. -5 plus 4 is -1. The next piece of our range says we hit all of the y values between -1 and 3. All right, the third piece is actually very, very easy. On the third piece, the expression for y is just the single number 6. We will get just the single number 6 in our range from that. And finally, on the fourth piece, we start with x is greater than 8. We need to multiply our x by -2. So -2x is less than -16. What I want to have here is -2x plus 4. So I'll add 4 to both sides. And I get -2x plus 4 is less than -12. So on that piece of our range, we hit all of the y values that are less than -12. Okay, how do we put all of this together to find the range of our overall function? Well, I'm going to turn to a number line again. And then, let's see. The numbers that I have as endpoints, I think the smallest one is that -12. And then I have a -6 and a -1 and a 1. And then I have a 3. And the last number I have is a 6. Again, I just went through and found all of the endpoints of those intervals that I just found. And I just need to get them onto a number line in order. If you miss one, you can just slip it in between. Give yourself space. Now I'm going to go through my intervals and mark what I have. My first interval, I have all the numbers between -6 and 1. The first piece of my graph is going to hit all of the y values between -6 and 1, including -6 but not including 1. So I'm going to have a filled in dot at 6, an empty dot at 1, and all the points in between. There's the first piece of my interval. There's the first piece of my range. The second piece of my range, my y values will hit all of the points between 3 and -1, not including either end. So I'll have an empty dot at -1, an empty dot at 3, and everything in between. That's the second piece of my range. Third piece of my range is very, very easy. I have just the single point 6. There's my third piece. And then the last piece, I have all of the points to the left of 12. That's my fourth piece. Those are all of the pieces of my range. I want to get all of the points that are in at least one of these. So I'll have all of the points to the left of -12. And then looking at these two overlapping pieces, I'll have -6. I won't have +3, but I'll have everything up to it. And I have all of the points in between there. And then finally, I have just the single point at 6. To write that in interval notation, I have everything to the left of -12, and then I have -6 up to 3, and then I have just the single point 6, which I'll describe by writing it in set brackets. There we go, there's our range. It was a little bit harder to figure out than the domain because the range of each piece wasn't immediately told to us. We had to do some algebra involving inequalities. And it was also a little bit trickier because we had to remember that when we have an overlap like this, well, it doesn't matter. Those points are in the range at least once. They're in the range. When we're looking at the graph, we'll play a very similar game. When we wanted to find the domain from a graph, we flattened everything into the x-axis. When we want to find the range from a graph, we flatten everything into the y-axis. So looking at this function, well, this piece flattens into the y-axis like this. It gets us the points from 3 up to 4. This piece flattens into the y-axis like this. It gets us the points from -3 up to 2. This piece, and then this piece, will flatten into the y-axis like this. It gets us the points starting at -4 and then going up into points that we already have. Once we've gone up into points that we already have, we're not getting any extra points. So what do we have here? When we want to find interval notation on the y-axis, it's helpful to turn our head to the side because we want to go from the bottom to the top of the y-axis. So we have -4 up to 2, union with that second little piece, 3 up to 4. And there's our range. We found that exactly the same way we did the domain, but we had to know what to do when the pieces overlap. And what we do when the pieces overlap is just take everything in the overlap as well.